Hello guys, I'm a teacher Olimboka Nsejuga Masame. Welcome to Olimboka Physics. I have a question below from AF Abuti, exercise 23, question number 5, concerning the concept of refractive index. If given the microscope that is focused on a mark on a table, and the mark is covered by a plate of glass that is got 2 centimeters thick. That microscope is raised a little bit to a distance of 0.67 centimeter for a mark wants to be in a focus. Okay, we have given we asked you to find the refractive index of the glass. Let us consider the diagrams below that illustrate what happens from the questions. We have a simple microscope. Yes, I use the simple microscope, the traveling simple microscope. And this is a mark. I use this mark as the rounded object. And I take just this mark as a rounded object. And this is a scale that is beginning from 0 up to any length above zeros. And this object will be focused at the distance c according to the properties of this length used in this simple microscope. And this distance c is actually a focal length for and this object is at a principal focus for a particular length. Okay, and so when we take the glass block and we put on the mark, this glass block must have the size of approximate equal to the focal length of the given traveling microscope. In order this traveling microscope to focus somehow this image, this visual image of this mark clearly on observer eyes. Okay, in order to do so, this traveling microscope at this part will be adjusted a little bit up towards a distance b, and this we record the distance b, and also at the same times from this other scale, the right scale, we record a distance a from 0, and this is for left scale we record just a distance b from the surface of the glass. And at this point is where now this image, it's apparent, this visual image will be focused clearly at the point where we have a distance b and from the surface and a distance a from the bottoms, from where the object, the first object was. But this one acts as a second object, but it is the image of this first object. It acts as a second object. Then you can focus this second object clear at a certain distance from the surface of the glass, which is distance b, or from this bottoms, or from the mark to this distance a. Okay, after understanding the illustrations of the diagrams above, let us take a look first on how we can relate the refractive index of any materials with the real depth and with the apparent depth, which is from here surface to this visual image that formed. And real depth is from the surface of the glass to the bottom of the where the object or the mark placed. Okay, let us consider the diagram below. We have a object at the bottom. This is the glass. As we put on the object is below, and we put on the glass. And now, from principle of reversibility, the light will always take the same path as the one taken from the beginning. Okay, now instead of light move from the air to glass, it's now light move from the glass to air, and now the glass is acting as the first media, while the air now is acting as a second media. And now the incidence angle for the glass to air interface will be equal to I1, which is equal to I2 of glass, and refracted angle at this air media is equal to R, or which is equal to incidence angle for media 2, and also this is equal to incidence angle for media 1. Remember, for the alternate angle, this angle I1 is equal to this angle I1 also for the air glass interface. And also after this refracted rays, we extended it backwards, the dotted line, until at a position where we can see the visual image. This apparent rays that we extrapolate backwards to this point, it is where we get the visual image. And from a distance I to m, this is the apparent depth for this visual image, while this real object, the distance O to m is equal to a real depth, and we have a distance m a as opposite for this angle r, which is the same as this refracted angle, as from these angles are corresponding angle. As you can see, this is the angle corresponding angles, and also this is opposite to this incident angle. Okay, and let us see another formula for a refractive index when we have a media 1 and media 2 is equal to constant, and this is incidence for medium 1 and this is incidence for medium 2, or is equal, we can, or is equal to refracted angles. Okay, you know that refractive index for medium 1 is equal to refractive index for glass, and for medium 2 is equal to refractive index of air, which is approximately equal to 1, and this the corresponding incidence angle and the refracted angle. We know that when we consider triangle MIA, and also we consider a triangle MOA, we will have the relationship, as you can see below, the relationship for the sine, which is opposite and to hypotenuse, that is AI, and for this triangle is equal to MI, that is opposite for hypotenuse, which is OA. And then we substitute to this first equations, and then we place this n1 to n for sub g, and this n for sub a. After that, m and m is constant, we cancel out, and then finally we get the relationship, as you can see here, OA to IA. This is the hypotenuse, or OA to IA. As when we assume that this eye, we position this eye close to the normal, as we move this eye towards the normal, we know that this AI will be parallel to IMs, and this AO will be parallel to OMs, and this angle R and I is very small, approximate to 0. For these conditions, now we know that the OA will be equal to OM, which is equal to real depth, and the AI is equal to IM, which is equal to apparent depth. Okay, this is how we prove for a given media, two medias, the refractive index for the case of real depth and apparent depth is obtained through this way. Okay, we will use these relations just to find refractive index when we determine it by using the traveling simple microscope. As we can take we must identify where we have a real depth and where we have a apparent depth. As you can see here, the real depth is equal to A minus B, and apparent depth is equal to C minus B. Let us just remind ourselves from the illustrations above here. This is a length A, and length B is recorded from the surface of this glass to this point, while the length A is recorded from the bottom as the object is up to the point where the simple microscope is adjusted in order to focus this visual image clear, which is a length A. Then when we take A minus with B, we remain with this thickness of the media, which is glass here. And for apparent depth, we know that apparent depth is from the surface to this visual image. Now it's from this surface to the visual image. How we can get this? We can get this when by taking the difference of from a thickness of this glass, which is the thickness is the approximate equal to the focal length where the object at the beginnings is focused clear to the eyes of the observer, and this distance C is what equal to focal length, and this is by any means approximate or equal to the thickness of the given medium in order this microscope to focus the image in one's eyes. Okay, we can take this C, which is equal to this thickness, and we minus with this B in order to get the apparent depth. Okay, from there we can just substitute the value of A, which is equal to B plus C, and the hence will remain with C as a real depth, as we know from the beginning, and then C minus B, which is apparent depth. When we substitute the data, so our final answer will be equal to 1.5. Thanks for watching. Please like, share, comment. Don't forget to subscribe this channel for more videos like this one. Thank you.